Welcome to this presentation regarding to the data science, a practical example where the data scientist is going to work with data related and we want to extract regarding to statistical analysis or another models and another schemes, how to extract information that we required and interpret these results, these outcomes. Here we have an example. I'm going to read a question regarding to using a data set. We're going to answer question regarding to diversity, equity, and inclusion that we have. Using the data set and question below, conduct analysis and interpret a short presentation regarding to, well, we're going to assess if, first of all, the question. The question is the DEI, data defined for diversity, equity, and inclusion, heads is concerned with the lack of equal treatment in the company for diverse employees, black versus white, woman versus men, and ask you to verify these with the data on salaries and employee engagement. What do you include based on the available data? If you could get access to additional information about employees to answer this question, which variables will you have added to your analysis and why? So here, first of all, we now how to assess if you are paying more for white or black people, or you are paying more for men or women, or is equal. So to answer this question, I have to develop Anova, the definition of Anova that stands for analysis of variance. It is a statistical method used to analyze the difference among group means in a sample. Anova tests whether there are statistical differences. Anova tests whether there are statistically significant difference between the means of three or more independent groups. It essentially compares the variance between groups to the variance within groups to determine if the difference among groups means are likely due to random variation of or if there is a systematic effect present. So ANOVA can be used for various purposes, such as comparing the effectiveness of different treatment or interventions. Another one, analyzing the impact of different factors on an outcome variable, or determine if there are differences, like this is the case, we're going to analyze this, determining if there are differences in means across multiple groups or level of a categorical variance. So here we have the specific example that we have, that is determining if there are differences in means across multiple groups or levels of a categorical variable. Then we have here the code. We import pandas. We import as well from SciPstats, if one way, and the other to plot how diverse to import the dataset that we already in the previous example, in the previous videos, we eliminate duplicates. We get the, well, after this, we import the dataset as well to that was pre-processed before to get a better data access with the depuration, the dropping duplicates, etc. So here we define a function to call obviously to the race and salary and the data set as well. So in races, get the unique variables of the data set and race for the race columns. We initialize a salary data. We create here an empty list of salary data by race, and we iterate over each race here to could be to analyze if the salary is equal to each race. So we have here the Anova result with the function and with the results that we get in this iteration before. We print the race column and Anova result to visualize the interpretation among the data. And as well, here we plot to visualize as well the data that we want to analyze. Then we have to remember that the output of ANOVA typically includes an F statistic and associated p-value. Now, if the p-value is below a predetermined significance level of 10.05, it suggests that there are a significant difference between at least two group means. In this case, one group we are analyzing with the salary, and another one that we're analyzing is the races. If the p-value is above the significance level, there is insufficient evidence to reject the new hypothesis, indicating that there are no significant difference among the group means. So remember, if the p-value is above the significance level, there is insufficient evidence to reject the new hypothesis, indicating that there are no significant difference among the group means. So remember, if the p-value is above the significance level, there is insufficient evidence to reject the new hypothesis, indicating that there are no significant difference among the group means. Okay, so in this case, we call the ANOVA function to see the result. Now we run the code to see the results that we get, and we run this. It's going to take some seconds. Okay, it's processing the data. Here we have the results. So for salaries across races, we get the F one-way result. One way because we have only one group. For two-way ANOVA, which involves two independent variables, and factorial ANOVA that is more than two variables. Here we are analyzing one, for that reason is one-way ANOVA, so we get the statistic that is 1.28 and the p-value that is 0.269. So this value, what it says, now we have to remember, if the p-value is less than 0.05, we accept the new hypothesis that there is a significant difference among the variables that are we analyzing. Out of here, the p-value is greater than or 0.05 significance level, then we have to reject the null hypothesis, indicating that there are no significant difference among the group means. So now we are going to see the graph to see this result. As we can see here in the graph of the salary distribution across races, we have here the races and the salary. We can see that the mean is almost equal to each one. Now we can see here a slightly variation here out of in the whole data that we have. We could see an average mean among each race throughout the salary. That's the reason why we can see here a remark and indicating of a significant difference among the mean of the salary they receive of each race. So here we have the code related to now for the gender in the case of their salary. So here we import, we define. So here we have the function to do the same as the previous one. The gender, to know if there is a significant difference among the gender and the salary they receive. So we use the data set, the gender column, and the salary column. So we get the unique values of genders. We create here an empty list to store salary data for each gender. We iterate here over each gender to see for a specific gender the specific salary they receive. And then we define here from our result what we get from the salary data by gender that we are appending here in the empty list to attach the specific gender for the specific salary they receive to see if there is a significant difference or not. Okay, to print there, we create here to visualize the results as well. So here that we get the p-value. This is the result that matters in this case is greater than our significance level, that is 0.05. Then again, we have to reject the new hypothesis, concluding that there is insufficient evidence to reject a new hypothesis indicating that there are no significant differences among the group means. As we could see here, I'm going to show you the graph. As we could see here in the graph, we see to all the genders that are the same amount of salary, the same mean, the salary that they receive. So we conclude that there is no significant difference among the salary they receive from each gender. So here we procedure again, but in this case to know if there is a significant difference among the races, but in this case from the engagement that they have with the work. The manager is trying to know if there is an engagement with the work to all the races, or there's no different. If there is no differences among the races with the engagement that they have in the job. So we do the same procedure as before, and we iterate to all races with the engagement that they have with the work. So we are including this, appending this in this list, the specific race with the engagement. And we are running the Anova result here, printing the result, and we are getting this plot. So running this code, we have the p-value is greater than the 0.05 significance level. So again, we could conclude there is no significant. We conclude that there is insufficient evidence to reject a new hypothesis, indicating that there are no significant difference among the groups of the race column and the engagement that we have with the company. Now we are going to show you the graph. Okay, as we could see here in the graph, to all the races we have, we could see that we have almost the same mean from the engagement survey that they have with the company. So here we could say that in some cases, to all the two or more races that we are listing here, they have a slow engagement with the company, although is no a significant variation or significant difference among the other races as well. So we define that there is no significant difference or almost equal to all the means that we have to all the races with engagement that they have with the work. And for the last part, we do the same now for the gender and engagement. So we do practically the same. So in this case, we get the following results. The p-value is 0.52. Then we again are rejecting the new hypothesis, indicating that there are no significant difference among the gender and engagement survey engagement that they have with the work, following by the graph. As we could see the graph, There is no difference amount. They have the same mean with the gender and engagement survey. So we could say to remember that, first of all, Anova stands for analyzing the difference among group means in a sample. Anova tests whether there are a statistical significant difference between the means of three or more independent groups. In this case, we only have one way Anova, there's one group. So essentially, we compare the difference among the groups that we analyze. Then we have to remember the output. If our p-value result is less than our significance level, 0.05, it suggests that there are significant difference between at least two groups. If the p-value is less than 0.05, if the p-value is above the significance level, more than 0.05, there is insufficient evidence to reject the new hypothesis, and you indicate that there are no significant difference among the variables that you are analyzing. This is a practical example that a data scientist has to do to a specific question regarding to data analysis. Thank you so much for watching. We like to see more content like this and more information regarding to data science related to specific statistical analysis or scientific questions. If you see this content useful as well, don't forget to subscribe, like this video, and comment below what other videos do you need, or share if this information is useful for someone that need required information for this. Share with that person. So thank you so much. Have a great day.